Okay, so the unit we're doing after the first test involves section 5.8, which really isn't anything new from what you did on the first test. You're still dealing with right triangles. And then I also like to include section 7.1 and 7.2. What's going on in all three of those sections that's the same is that you're learning to solve a triangle. Okay, now this in 7.1 and 7.2, you're going to be solving something called an oblique triangle. And so an oblique triangle means there's no right angle. Okay, no right angle. Okay, so that's what's new about 7.1 and 7.2 is you don't have a right angle. So here's the issue. You can't use SOHCAHTOA or the Pythagorean theorem. Pythagorean theorem. It's probably the biggest mistake people make. So it's hard to let go of those. So in 7.1 and 7.2, you're learning how to solve triangles that are not right triangles. And so you're going to have to break a habit. You can't use SOHCAHTOA or the Pythagorean theorem because they apply when you have a right angle in your triangle. Okay, so let's go ahead and take a look at the two basic ways the triangles look. Here's one where all the angles are acute. It's called an acute triangle. And then if you have a big angle, like angle A bigger than 90, that's an obtuse angle. So this would be called an obtuse triangle. So that's what we're looking at is these two types. Okay, and it really doesn't matter which one you're dealing with when you're making use of the law of sines and the law of cosines. You kind of approach them in a similar way. Okay, so the first thing I want to look at is the law of sines. Okay, so the law of sines says that the ratio of the side of a triangle to the sine of the angle opposite it is going to be constant. So A over sine of A is going to equal B over sine of B is going to equal C over sine of C. Okay, so the lengths of the sides wind up being proportional to the measures of the angles. Right now, what's important is that it works whether the side lengths are on top or whether the side lengths are on the bottom. Okay, what's important to notice is that side A and angle A are within the same ratio, and side B and angle B are within the same. Okay, C and C have to stay within the same place. All right, so now let's do two examples in this video, and then we'll do this one case, this one situation that can be a little more complicated, but these are pretty straightforward. Okay, so let's look at what we're given. We were given angle A, angle C, and the length of the side opposite angle C. Okay, so when you're trying to set up this, you're going to want to make sure you use this information. You need to have three, look back up here, you need to have 3 out of 4 pieces together. You need to have 3 out of 4 of the pieces of that proportion. You have to know 3 out of 4 of them in order to be able to find the missing one. So I always look for where I have the angle and the side opposite it. I know I'm going to use that as one of my ratios, okay? And then I have angle A given to me. So I'm going to find little a first, okay? So I might set up little a over the sine of angle A, which was 64 degrees, equals little c over the sine of 82 degrees, okay? All right, now, if you will set it up so that the unknown is in the top left corner, it does make the algebra component feel a little bit easier. Doesn't matter really, but it's just easier when you do it. Okay, so what we're going to do is multiply both sides by the sine of 64 degrees. Okay, so that's going to cancel out. We're going to have little a equaling 14 times the sine of 64 degrees, all divided by the sine of 82 degrees. Now this is multiplication, but you don't actually have to type the multiplication sign. Your calculator knows to do that if you don't write something. So the way you enter it is 14 sine 64. Make sure that you're in the correct mode. So, don't forget to check your mode. You need to be in degree, not radian, right? So do 14 sine of 64, hit enter, but don't shorten that. Leave all that on your calculator screen. Then divide by sine 82. Okay, and you should work this out while we do it to make sure you're not having issues entering it. All right, and then on this one, I didn't tell you this, but they wanted us to round to the nearest tenth. So if I round to the nearest tenth, little a would be about 12.7, and the units would be centimeters. Okay. All right, now, something I could have found right off the bat if I had wanted to would have been angle B. So I could have done that to start with. Since I had two angles, it's real easy to find the third one. At some point, you need to do that. So I can do that just by taking B, angle B, is going to equal 180 minus the 64 and minus the 82. Okay, or you can add the 64 and the 82 together first and then subtract from 180 to see what the missing angle is. So it's exactly 34 degrees. So I know this is 34 degrees. I found A, and it was about 12.7 centimeters. So now I'm looking for B. Now I think it's important when you do this that when you set up your proportion that you try to use the information you were given, not the information that involved you rounding. So I wouldn't use A divided by sine A because that was rounded. I would go back and I would use B divided by the sine of 34. I would go back to C divided by the sine of angle C because that was given, that wasn't rounded. So you see it has a very similar feel. So we're going to come in and we're going to multiply by the sine of 34 on both sides. Because of the way we set it up, it has a similar feel. And then we're going to type in 14 sine 34 divided by, or you could hit enter first. Okay, it's probably better practice. Okay, divided by sine of the 82. And we get it to be about, it was rounded, so let me change that to approximately 7.9. And that was a side, so that's centimeters. Okay, so about 7.9 centimeters. And then I think it pays to come over here and just take a look. So this was 34 right here. Little a was 12.7. And little b was 7.9. And just take a look to make sure the shortest side is opposite the smallest angle and that the largest side is opposite the biggest angle. And then that's kind of a rule of thumb to double check on mistakes you might have made. Okay. All right, so let's try another relatively typical one. Okay. So here's checkpoint 2. So we have a triangle. And angle A was 40 and angle C was 22.5. So this turned out to appear to, this is probably going to be an obtuse triangle. B is going to be rather large. I didn't find B first last time, but if you have two angles, there's no reason why you can't just go in and get the third one at any point you want to. So why don't we go ahead and get that out of the way. Okay. Okay, and we wind up with angle B being 117.5 degrees. And it's exactly that, so I'm not using the squiggly, the approximately equal to, I'm using the equals. Okay. All right, now I'm looking though at the fact, let me change that to red because I like to remember what it was I was actually given and what I found. Okay, even though it wouldn't really matter, I like to look at that. I had no choice on this one but to find angle B because you see I didn't know little a or little c, so I didn't have a completed ratio. And if I don't have the side and the angle opposite that side, then I won't be able to set up a proportion that has 3 out of the 4 parts filled in. So I had to find that 117.5 degree angle, and then this is going to be one of the ratios. Okay. All right. So let's suppose I'm trying to find little a. Then I like to set mine up with the unknown I'm finding on top. So little a would be divided by sine of 40, and then side B divided by the sine of angle B. Okay. All right, then it's pretty much has the same algebraic feel because of the way we're setting them up with the unknown in the top left corner. So far it's had a similar feel when it comes to solving. So I multiply by sine of 40. I get a equals 12 sine of 40 degrees, all divided by the sine of 117.5 degrees. Okay, so enter that in your calculator. And what I get on that is about 8.7. And we weren't given any units on this, so A turned out to be about 8.7 is what I know. Oops. Okay, let me go ahead and put it on here while I'm at it. And let me go ahead and put the 117.5 right there. All right, so now I need to find one more thing. I need to find little c. All right, now when I go to find little c, I'm going to go ahead and keep the right-hand side the same because I didn't do any rounding on that one. 117.5 was exact. And then I'm going to set it up with little c over the sine of 22.5 degrees. Okay, so it has just a similar feel. Now, it won't always work out this way when you set it up, but you control how you organize these. And so I find if you put the unknown in the top left corner, you have a less of a chance of making a careless error when you do the algebra from there to the end. Okay, so now let's do that one. 12 sine 22.5 divided by sine of 117.5. And I got about 5.2. Okay, so let me put the 5.2 here. Let me put it over here. And you want to either look at the picture or at the other side to make sure the longest side is opposite the biggest angle. Okay, so that you can at least check that it seems right. Okay. All right, and those are two kind of classic examples where you're using the law of sines to solve a triangle, and these triangles, see, are not right triangles. So we couldn't use the Pythagorean theorem to find missing sides. Okay, you know, once we found one of the sides, we couldn't use the side we were given and the side we found. We couldn't use the Pythagorean theorem to find the third side. You have to fight that urge. That's the biggest mistake people make. It's trying to use SOHCAHTOA or the Pythagorean theorem when you can't. You can't because you don't have a right triangle here. Okay. All right, so I encourage you to go ahead and read section 7.1. By the way, I didn't derive the law of sines. If you're interested in that, you can read about it. I thought we would spend our time looking at examples and working through some sample problems. Okay. All right, now I'm going to stop this video, and my next video is going to also be law of sines, but we're going to be looking at the case where we're given two sides in an angle. Okay.